forget I'm on camera sometimes. Thank you for clipping that in like 30 seconds. So models trained on students from a single population, urban, suburban, or rural, work well on that population, but they're inappropriate for different populations where they perform just barely better than chance. That was an important finding because a lot of these models get built just on one population, right? A lot of people who build models just get a convenience sample and they just work with it. You can't do that. The models trained on students from all three populations work for the urban and suburban students, but they still don't work as well for the rural students as a rural-specific model. This was kind of a surprise to us, because we thought originally, the urban students come from a different cultural background mostly than the suburban and the rural ones in our sample. We thought maybe culture would matter, in which case maybe the urban ones are different. Or the urban and rural students are lower SES than the suburban. Maybe SES matters, the suburban should be different. But it was urbanicity that seemed to matter. So this is kind of one indicator that you really need to pay attention to these issues of population when you're collecting your data to build your models. Don't just use a convenience sample. In our work with Reasoning Mind, we've gone on to continue doing that and actually gotten from different regions of the country. So it's nice to be able to detect these things, but does it really matter? So we applied the detector to 1,393 students who had previously used assessments, and we got the state standardized exam scores for those students. We found that there was a correlation between these kind of these indicators of engagement and standardized exam score. For example, a correlation of -0.36 between gaming the system and standardized exam score. Correlations of -0.2 for boredom, +0.36 for engaged concentration. When we put them all together, we can actually get a model that gets a correlation of 0.765, which indicates that, and we had learning in there too. Affect and learning assessments can predict over half of the variance in state standardized exam score. So it's a pretty decent predictor. We also applied the detectors to data from 4,000 New England middle school students using the system, 2 million actions within the software. Again, they have much more bigger populations now, but since we wanted to do several year longitudinal research, we could only go with what they had a decade ago. So we took these students and we followed them into the future. We said, can we figure out which of these students went to college? So we got the data from the National Student Clearinghouse about every student in the sample. Did they go to college? And we were able to predict 69% of the time from middle school whether the kid would go to college or not. It turned out that engaged concentration and carelessness were positively associated with going to college. Gaming system, boredom, and confusion were negatively associated with going to college. You might say, yeah, I see a couple of people looking confused. Confusion is associated with going to college. Sorry, carelessness is associated with going to college. So what's this mean? Well, it turns out that carelessness is positively associated with college until you control for student knowledge, and then it's negatively associated. Carelessness is the disengaged behavior of generally successful students. This is something actually that goes all the way back to Clement's 1982. So we're replicating I won't say a well-known finding, because I don't think carelessness research is particularly well-known in general, but it's a known finding, it's reported previously. If you're doing pretty well in school, carelessness is the way you get disengaged. If you're not doing very well, gaming the system and other stuff like that is more how you get disengaged. But off-task behavior was not correlated at all so far in 80s. That's actually also not an unusual thing. Off-task behavior often gets relatively small correlations to outcomes. And when it does get correlation to outcomes, it varies on whether it's collaborative learning or not. There's a lot of factors that mediate that. So it's kind of an issue because our teachers in assessments often spend a lot of time trying to get students to stay on task, and they don't spend as much time focusing on gaming the system or boredom. So the same stuff actually also predicts whether you go to a selective college. 76% of the time from middle school we go to selective college. Selectivity was based on Barron's ratings. We used the selective, non-selective breakdown. For example, A&M, selective. Actually, I don't know a non-selective college. I'd like to give an example. A community college would be non-selective, but there are also a lot of 4 years that are not selective. And it turns out also that our metrics of engagement in math in middle school predict whether you major in STEM in college. Students who are knowledgeable or careless are likely to have STEM majors. Students who game the system are less likely to have a STEM major. And that gets a Cohen's D of 0.573. So it's a pretty pretty sizable effect. And we can tell from middle school, 68% of the time, whether somebody's going to major in STEM in college from their engagement and learning in middle school now. So we published it in 2014. This year we just submitted a paper about what happens to those kids who gain the system in middle school. Anyone want to guess? These are the students who went to college but they don't major in STEM. What do you think they major in? That's actually a type of STEM in our classification. So yeah, if you gain the system in middle school, you're less likely to major in computer science. No, but that's a good guess. Any other guesses? Close. Close. We don't have a pre-law thing, so we can't look at that. But it turns out business and social work are the two most common majors. And you know that social work in a lot of ways is about trying to figure out how to work systems to help create positive outcomes. So that's actually kind of a reasonable thing. Business, well, our society has some problems right now, so. I keep forgetting I'm on camera. So, future work, we're going to go forward further still. We're going to look at post-college choice of job and success in career. So, once these population lands on LinkedIn, it's going to be a lot easier to follow them, and we've gotten consent from a large number to follow them on LinkedIn. So how do we use this information? We can use it in 3 ways: advance the science of learning, empower teachers and guidance counselors, and automated interventions. Many scientific discoveries have been enabled by these methods, and my group's not the only one to have done this, but I'll give a quick sample from my group. For example, we've done research on the short-term impacts of affect on learning. This research talked about the long-term impacts, but what are the short-term ones? It turns out that extended confusion and frustration are bad. There was a long body of research for about a decade where confusion would be correlated to long-term learning outcomes. And half the time it would be hugely positive, and half the time it would be hugely negative, and no one really had a good model for that. We found that extended confusion was bad. But if they resolve the confusion, if it's brief, it's good. That's even true of frustration. Even if you get frustrated, it's okay as long as you resolve it. Boredom, however, is bad no matter how long it occurs. We've done research on how the design of curriculum materials impacts disengagement affect. We did this research in cognitive tutors. It turns out that very concrete mathematics problems that have rich cover stories are good for affect engagement. Very abstract problems that just give an equation, those are also good for affective engagement. But in between is not so good, so-called hokey problems. So if you have a rich math problem about the Iditarod dog sled races and figuring out how much food the dogs need to eat and such, kids get engaged by that. But if you say, Martha bought 6 sweaters and Jim bought 4 sweaters and the sweaters cost $10, how much for each sweater? Kids do not get engaged by that. It's funny because every middle school kid knows that, and still teachers give those kind of problems. And in fact, you can look at the difference. Like if you have the hokey problems, you see there's about double the gamut. If you have no scenario at all or a rich scenario. This kind of, by the way, flies in the face of some of the seductive details research, which suggests that seductive details can actually reduce learning. But a lot of that seductive details research was done in lab studies where there was nothing else to do. We also found that ineffective hints lead to more gaming, not shocking. Highly abstract hints lead to more gaming, and unclear user interfaces lead to more gaming. Second thing, empower teachers and guidance counselors. We can give them data on student long-term trajectories along with each student's risk factors. The key here is not to say, this kid is not going to go to college, ignore them. The key is to say, this is why this kid is at risk of not going to college. So here are some of our guidance counselor CUS reports that we're partnering with the city of Bellingham, Massachusetts on, where for every kid we have a report as to what their biggest risk factor is. So for example, this kid is reasonably engaged, actually. This kid's reasonably engaged, but they're struggling with math. So this might be a kid that you want to get them after-school tutoring opportunities. This kid, by contrast, is getting very bored, even though they're learning a lot. This might be a kid who, they're going to not do as well because they're not as engaged. So maybe you want to do something to get them more engaged, like, for example, a summer program that about opportunities in STEM. The key is not to say this kid's going to fail and this kid's going to succeed, but to say here's why every kid is more at risk or less at risk. Automated interventions. This is actually an old one. This is my doctoral dissertation work. I haven't done as much work on automated interventions because most of my partners are more interested in the reporting than the automated intervention. And I don't build systems myself, I partner. But this was Scooter the tutor. Scooter looked happy when kids used the software appropriately, looked angry when they used it inappropriately. The teenage boys loved this. They have little competitions to see who could get Scooter angry faster, so that wasn't a good design. But it reduced gaming by half and helped students who game the system catch up to the rest of the class. It was kind of a short-term intervention, but it kind of shows that you can do this kind of stuff. So the big idea is that thanks to big data now becoming available on student learning, and a combination of data mining, knowledge engineering, and field observation work, we can make inferences about students in real time that are predictive of their long-term outcomes. So the eventual goal is track a student's engagement now, predict the longer-term impact, intervene to help re-engage students and support their learning, whether it's a teacher or an automated system doing it, and try to help create an educational system that's more sensitive to individual learners' needs. So thank you for your attention. Let me give the quick commercial at the end. You've taken my MOOC. It's now a free online textbook, Big Data Education, which is open on the web. You can watch one video in just on my webpage, no login. We've got a MOOC, Data Analytics and Learning, on edX right now. The MOOC that you took is going to be done this spring on edX. I don't know the start date yet. We're moving from Coursera to edX, which is definitely a story I don't want to put on camera. All our lab publications are available online. Just Google my name. And we have a Twitter feed, a Facebook feed, and even a Weibo feed. So thank you very much for your attention. I'd be delighted to answer questions. Yes?
Yeah, can you talk a little bit about the IRB process, or how do you get consent?
Sure. So there's multiple parts to it, right? A lot of the research we do, actually most of the research we do falls under exempt. Yeah, I see a couple people look, it falls under exempt. Field observations are publicly observable behavior, and we don't actually get the kids' names. I don't have the kids' names on some hard drive at my university. We discard, when we do the field observations, we get the kids' names and logins while we're out there, but we don't take them back with us. We send them to our partners who link the data for us and get it to us. When it comes to the long-term stuff, Sysmints has to have the kids' names because they're the content provider. They do the linking. Worcester Polytechnic has all the identifiable information. Teachers College Columbia doesn't. That's how we're exempt. Other questions?
I know you talked about the camera. What are the reasons for moving to edX and leaving Coursera?
Can we turn off the camera?